Hey guys, welcome back. Next topic in differentiation topic is differentiating trigonometric functions. Till now we have done the derivative of logarithmic and exponential functions. Next functions type of functions are trigonometric functions. So the moment we say trigonometric function, the first function that comes to our mind is sinusoidal function, which is sin x. Okay, so what could be the derivative of sin x function? So here is the graph that is given to you, graph of sin x, which is in green. This graph is of sin x. What could be the derivative of this sin x? So let us derive this function intuitively, right? Although the whole derivation of this function, derivative of the function sin x is derived using first principle of differentiation, which is not in your syllabus. But what could be the derivative of this sin x? Let us see. As you can see that as you know that the derivative of any function gives you the gradient of the tangent at any point. For example, if you're given any function, let us say x square, its derivative is 2x. So what this 2x says is that if you take any point on the graph y equal to x square, right, and you draw the tangent at that point, so the gradient of that tangent, gradient means the tan theta of the angle that the tangent is making with the x-axis, right? I know that I have spoken so many words, technical terms, but if you listen this closely, that you have been given any curve, let us say y equal to x square, and at any point you are interested in finding out the gradient, interested in finding out the derivative. So that derivative gives you, at any point, gives you the slope of the tangent drawn at that point, right? What is the slope of this point, of this tangent, right? So if I'm saying that I'm interested in finding out the gradient function, derivative function, so it basically says how the gradient or the slope of the tangent at any point of this curve y equal to sin x changes, right? Means I need to derive the gradient function. Okay, so as you can see that this red line, which is y equal to x line, this its slope is always 1, right? And at x equal to 0, what can I say? That since this y equal to x line is a tangent to the curve y equal to sin x at x equal to 0, right? So its gradient at x equal to 0 is 1. Although you will notice that this is not appearing to be a tangent because it is not touching. Answer is it is touching, but it is crossing. So it is a special type of point on the curve, and this point is called point of inflection, right? This term I think you have heard in your AS level. So here it is not so important, right? The important point is that the gradient, if we omit this graph of y equal to sin x for x less than 0 and just concentrate on the positive x-axis, so this line y equal to x line whose gradient is 1, so at x equal to 0, gradient of y equal to sin x is 1, right? Now you keep on changing these straight lines, means you draw the tangent, let us say at this point like this, then at this point you draw the tangent is like this. So what you can see here, that as the graph is slightly, its slope is going to decrease, so we say that the tangent slope is going to decrease. So value of the gradient, what I mean to say is, which was at x equal to 0, it changes slightly. And what will be the value of this gradient at x equal to pi by 2? So in the graph, as you can see here, if I omit these tangents, so at x equal to 0, let us draw the tangent. This tangent will be horizontal, okay, like this. So at x equal to pi by 2, not at x equal to 0, at x equal to pi by 2, the gradient of the tangent is 0, right? So that this gradient function started from the value 1 at x equal to 0, and it becomes 0 at x equal to pi by 2. Okay, what will happen after pi by 2? Let us see. So from 0 it is going to decrease, but in the negative direction. It going to increase, but in the negative direction. So mathematically or the value wise, the slope is again going to decrease. Magnitude wise it is going to increase, right? So it is going to decrease like this, and at x equal to pi, again its value this tangent will be like this. It will again cross the point x equal to pi, but this will be a tangent at x equal to pi, and slope of that gradient or slope of the tangent will be -1. So at x equal to pi, at slope is -1, at x equal to 0, slope is 1, right? I think you are arriving at a function which is following all these properties. What properties? This trend of obtaining the values at x equal to 0, 1, at x equal to pi by 2, the value is 0, and at x equal to pi, value is -1. Again, you can increase or you can extend this concept. At x equal to 3 pi by 2, again the gradient of the tangent is 0, and at x equal to 2 pi, you will get the original red line whose slope was 1, like this, y equal to x line. Okay, so I have some points below this graph. I will plot some points and let us see which graph will follow all these properties, all these points. Okay, so at x equal to, let us say this is my point pi by 2, this point is 3 pi by 2. Okay, this point is 0. So at x equal to 0, gradient is 1. Okay, so I have this point. At x equal to pi by 2, gradient is 0. At x equal to pi, gradient is -1. Okay, this is the point for -1. At x equal to 3 pi by 2, this point is 3 pi by 2, gradient is 0, and at x equal to 2 pi, value of the gradient is again 1. So, to my knowledge, I have learned that these points are always lie on a special type of function, which is just a small brother, or you can say the younger brother of sin x. We say this is cos x. Remember the values of cos x at these basic angles. At x equal to 0, cos x is 1, then its value decreases. X equal to pi by 2, its value is 0. In the second quadrant, it is negative, and it reaches to -1 at x equal to pi, and again it will obtain a value of 1 when whole cycle of 2 pi completes, right? So you have a function which is called cos x, only cos x will follow these properties. So I can say that the derivative function or the gradient function of sin x is cos x. Okay, you can sketch this curve. Okay, so here I have that d by dx of sin x is basically none other than the very well known function which is cos x. Okay, so now I have a list of all the derivative function. As I told you earlier, the proof of all these derivative of all these trigonometric function is out of your scope. We derived this using the first principle of differentiation. So you need to remember these functions, derivative function, and if I say that you need to remember only these three basic function, because you have to use the derivative of these sin x and cos x on and off. Okay, many times you will use this as far as you are studying mathematics course AS and A level. Okay, though all these functions, all these formulas will be given in your MF 19, right? You can use your formula sheet also, right? So derivative of sin x is cos x, and if you differentiate cos x, means second function, it is minus sin x, right? And third is d by dx of tan x is sec square x. Okay, similarly we have other three derivative function for the reciprocal functions, right? Now what will happen if I add a multiply, or if I multiply the angle, means there is a multiple of the angle, right? So if y is equal to cos x, what will be the derivative? You can derive these functions, derivative function, very easily by using the chain rule. Okay, chain rule means if you have a function y is equal to sin kx, where k is just a constant like sin 2x, sin 3x, sin 4x, any value, not just integer value. Okay, fraction also you can use. So it is just a constant. So you can assume that let kx is equal to t. So now the function y is now a function of t instead of x, and this is sin t, because kx you have assumed as t, right? So now what chain rule says, that now this dy by dx is that you will first differentiate y with respect to t, and now t will be differentiated with respect to x. Okay, you can cancel these t and t, you will get value of dy by dx. This is your chain rule, you already well known about this. So dy by dt means it is just cos t. Okay, and dt by dx means you differentiate kx with respect to x, you will get just k. Okay, derivative of 2x is 2, derivative of 3x is 3, derivative of pi x is pi. Okay, whatever is the constant, you will get just the constant. So cos t, so dt by dx is just k. Okay, so I have this, that dy by dx is cos t, replace the value of t as kx, so k into cos kx. Okay, so what you have learned is, what this chain rule simply says, that differentiate the function f kx with respect to kx first and then differentiate kx with respect to x. Okay, so derivative of cos x is k minus sin x, sin kx. Sin kx derivative we have just derived, k cos kx, and derivative of tan kx is k times sec square kx, because derivative of tan kx with respect to x is sec square kx. Okay, so this is how you can apply the chain rule, not even to these trigonometric function, but also to exponential and logarithmic function that we have already done, okay, in our previous lessons, right?